5.4, solving radical equations and inequalities. So to solve a radical equation, it's just like solving a different equation. You want to solve for x, and the way to do this is to probably raise each side to a certain power to get rid of the radical. Important that you need to check your answers, particularly when you raise each side to an even exponent. Let's go ahead and do some problems here. First of all, it looks like I want to solve for that x, so I have to divide by 2 on both sides and then square both sides. And when you square both sides, you've got to be careful. Check that answer again. So this becomes x plus 1 equals 4, and x is equal to 3. A quick check on here. 3 plus 1 is 4. This becomes 2. 2 times 2 is 4. The check works. Going to this problem, again, trying to solve for that x, I'm going to add 1 to both sides. I'm then going to cube both sides. And this becomes 2x minus 9 equals 27. Adding 9, 36, and dividing by 2 gives you 18. Let's see, if I put in an 18 here, I get 36 minus 9 is 27. Cube root of 27 is 3. 3 minus 1 is 2. Other things can happen, and this is an extremely long problem because the only way to get rid of these radicals is to square both sides. And look and see what happens when you square both sides. You're going to get a huge polynomial on that side. So it becomes x plus 2. That's what you get when you square it. The middle term is going to be 2 times x plus 2. And then the last one is going to be 1 times 1, which is 1, is equal to 3 minus x. Now, you still have this issue. So what you need to do is isolate that on one side and then square it again. So you're actually going to be squaring this twice. Let's see, 2 square roots of x plus 2. And interesting enough, this is a 3 on this side, and that's a 3 on that side. So when you subtract 3, those go away. And so now you have equals a negative 2x. Dividing by 2, this is whittling down real nicely. And now you square both sides. Then we want to put everything equal to 0 and hope that you can factor it, which we can. So this becomes x and x minus 2 plus 1. So my two potential answers are x equals 2 and x equals negative 1. Now, again, you have to check those answers because of the squaring. In fact, you squared 2 times. This would be the second time right here. So when I put those in, I get 2. And one way to do this is just make a table and see what happens in the table. So this is square root of x plus 1, x plus 2 plus 1. And this is square root of 3 minus x, and see if those two equal. You put in 2, you get square root of 4 is 2, 2 plus 1, put in 2, and you're going to end up with square root of 1, and that does not work. Put in negative 1, and you're going to have square root of 1 plus 1. This becomes 3 minus negative 1. This does work because 2 equals square root of 4, which is 2. So that means that this is only your answer. This is not your answer. Now, the last type of problem that we can have is an inequality type of problem. And this is where you have um, an infinite amount of answers. So again, the idea is to solve for that x. So we want to get rid of everything that we can to make it easier. When you square both sides, again, you're going to want to check an answer here, but this becomes x minus 1 less than or equal to 16. Some of you may be thinking about flipping that sign. Remember, that's only when you multiply or divide by a negative number. So this means that x is less than or equal to 15, and 0 would work. So if you plugged in 0 just to check it, you see that it's not going to work because 0 is going to give you a negative number here. So this makes this an interesting problem. You see, x minus 1 has got to be greater than or equal to 0 as well as that. So x has got to be greater than or equal to 1, or x has got to be less than or equal to 15. So, so the way that you could write this is all x's greater than or equal to 1, less than or equal to 15. And that would be our answer. Again, you could try a number. Let's try 2 and put 2 in, and you're going to see that that's less than 12. Harder problem because you have to remember what the domain is, and the domain would be that to help you with your solution.